Good evening, ladies and gentlemen, and thanks again for joining this Future Talk. And it's a pleasure to have you with us this evening. We're going to be talking about a very important topic. In fact, a topic where the country in South Africa is facing a crisis when it comes to mathematics. When you look at, for instance, the issue of our young people not reading without meaning, that issue is receiving a lot of attention these days. And in fact, we've started to see some programs that are supported by government, non-governmental organizations, and so on, that are starting to address the issue of reading. But the issue of mathematics is a crisis also that we have to address as a country, particularly because if you look at the issue of unemployment and the skills of the future, and even the skills of today, a lot of them require mathematics. You cannot be an artisan or technician or even participate meaningfully in the fourth industrial or the fifth industrial revolution without mathematics these days. We talk about artificial intelligence, coding and robotics, and all of these things require mathematics as a foundation to build on. At Future Nation schools, we do not do maths literacy. Why? Because we firmly believe that every child has the opportunity and the possibility of doing mathematics. What is required is for us as parents and young people to demystify mathematics so that we make it accessible. We make it fun to learn, and that way will pave the way for a lot of our young people to realize their full potential in a number of areas. If you look at our country as an example, last year in 2022, we had just more than 725,000 young people who wrote the National Senior Certificate, and Mr. Bete, that I'm going to introduce just now, will show later on that we only had about 275,000 young people who wrote mathematics. But when you look at the pass marks, especially that paves the way for us and young people to get into professions like engineering or actuarial science or data science or accounting and so on, you'll suddenly see that we really face a crisis as a country. And it is important for us to deal with the crisis of mathematics, to demystify mathematics. And with me, I'm not alone. I'm here with Ma'am Mampho Langa, who's head of our schools at Future Nation Schools. She has a master's in maths education and in fact has been teaching mathematics for more than 37 years. And on my extreme left is Mr. Lawrence Bete, who's head of our mathematics at Future Nation Schools, and again has been teaching mathematics for more than 27 years. And they're going to be unpacking the issue of mathematics and what we can do to make maths fun, in fact, to demystify mathematics so that a lot more of our young people can take up this subject, because it does really create opportunities for them and paves the way for their future world of work. So I'm going to not waste more time, and I'm going to hand over to Ma'am Mampho Langa, who's going to discuss the issue of mathematics. Over to you, ma'am.
Good evening, and welcome to our webinar. Before we even go into the talking of mathematics, let us try to define what is mathematics. According to research, they define it as mathematics as a branch of science that allows us to convert laws of nature into something that can be understood. Laws of nature, which implies it is a natural phenomenon. It might be a science of numbers, but it is a natural phenomenon. We'll talk more about that. There are three ways in which we use in maths. We either do it verbally, graphically, or even by examples. Before we even go anywhere, I want us to look at the history where it started. I'll use Africa as an example. We know about Mansa Musa, who was one of the wealthiest men in Africa. You can't have so much wealth without the knowledge of mathematics. The maths originated on people like that, and that was the 13th century when he became rich. And we know that some of the information was not kept, but we can determine that there was some maths involved. Also in Nigeria, there's a term that they use, ugoji maroon, which means 5 and a 10 and 5, when you take it away from 3 20s, which is equals to 45. So it means people were using that terminology to show that they can subtract 15 from 60 to get 45, which is a sign that they've been comfortable with multiplication and subtraction long ago, even before. Even the history of commerce, we used to have loans, credits, debits in their everyday life. So there was maths, people have been comfortable. It's not the thing that's happening now. We go to our Ndebele designs that have been there ancient years ago. The maths and the geometry that's involved there is precise and accurate. There are angles, there are circles, there are triangles, everything, tessellations. And all of this was just freehand. No ruler was used. We know Dr. Mahlangu can do that with ease, Esther Mahlangu. So there was some mathematics. Even till today, nothing has been recorded how these were done. So maths has been there long before we could even think about it. Our old grannies used to use hands to calculate even the nines. They will tell you 9 times 1 gives me that and all of that. They would just give you that just using fingers. Arms even to measure, they would tell you an arm is equivalent to a meter. So many feet would give me a meter or would give me a yard in the past, because we used to use the British system. Skin test, they would use a hand just to measure the temperature in an oven. I remember this game we used to play when I was young. We would put a string, and in the string we would make a circle, a very accurate circle. In that there was a diameter and a radius, and that was before formal education. Knuckles were also used as a calculator. Diketo, Khati, and Dibeke, a lot of maths is used there, but there was hardly any mathematics or formal education. Counting of wealth. People knew how to count how many cows they have without mathematics, which implies it has been there. Now, why do we have a challenge with maths? The language of mathematics, with the introduction of textbooks, algorithms, and everything, started confusing people. I've put in an example of limits there. In everyday language, limits mean something else. You can't go beyond something. But in maths, it's completely different, and it is used in calculus. The exponents. We grew up knowing this as 5 squared, but someone will say 5 to the power of 2. Some might say 5 exponent 2. Some might say 5 index 2. So on its own, that language is complex. Some even call the whole thing a power. Besides the language of mathematics, we have what we call dyscalculia. We all know about dyslexia because we talk about it in reading, when people have problems with reading, but we hardly ever talk about dyscalculia. With dyscalculia, students have a problem, first of all, to make sense of numbers. They can't calculate backwards, and students don't even know, the place values, or sometimes they get highly anxious when it comes to mathematics. So most of them have not been diagnosed with dyscalculia, and it is difficult to deal with it if it's not been diagnosed. And there's a myth that maths is abstract or it's difficult, but more than any other thing, we're not integrating maths with other subjects. What is the solution to this? Project-based learning is the solution. Most of our textbooks don't talk about project-based learning. It's just rote learning. Example, you move on just like that. But once we start engaging our students with real life, it will give them meaning, and they will be able to link it with their personal experience. What is project-based learning? Project-based learning is how you teach students to try and link what they learn in class and apply it into real life. It means you take the theory, all what you've learned in the classroom, into the practical life. And for you to master that, you should give students a problem to solve. And that problem, they should be able to something that they will continue wanting to learn more. And the problem you give them should be real so that it makes sense to them. And it should allow them to talk about everything. And they should be able to reflect and also be able to display what they will do. So with all of that, life becomes easy. What will they learn when they do project-based learning? They will have authentic understanding of mathematical problems. They'll be able to deal with things that are currently happening in the country and how to solve problems. And they will also have an in-depth understanding of mathematics. It will help them to have that active participation, permanent learning, self-confidence, team working spirit, problem solving, high order thinking, because they are dealing with something that is practical, something they can apply. Numerical skills that would come in calculations. These are things we do on daily basis. We do budgeting on daily basis. We interpret information from the graphs. We understand relationships between numbers. Trends, what is happening with trends? Data analysis, those are things we do all the time. Project-based learning, when you give them a problem, they can even come up with mathematical modeling. And we always feel like mathematical modeling, it's something they would do only when they are at tertiary level. They can do it as early as a foundation phase, because that's where they would get information, try to come up with a model. That model will be able to solve the problem they have. They would understand probability much better. I got this from an article in a newspaper. It says 100% risk-free first bet, up to 2,000 back if you don't win. We don't have something like that. It is something that would draw people to keep on betting, making bets. And if we allow them to apply this into real life, they'll analyze that critically. Up to 2,000 can be, you might not get anything back. So before betting or doing anything, if you understand your maths and apply it to real life, it makes life easy. We also have functions which are your graphs. These graphs can be used to analyze things like earthquake intensity measurements. Ask the students, can we look at the intensity? Can we put it on the graph? The acidity that we get in the water, we buy bottled water all the time. Can't we bring different ones? Measure it from the science, because it can't work in isolation from mathematics, and see how it works. The earthquake comes from geography, but we put it in maths. Sound intensity is mathematics. That can be linked with maths and be put into a graph. Expressing of larger numbers that you get in physical science, you get them in geography, can be used also in mathematics. More than any other thing, mathematics is beautiful, which tells us a lot that God is part of our maths. I've made this as an example. We can see how beautiful that rose looks like is because of the golden ratio. What is this golden ratio? If you take the largest distance in that rose, you divide it by the shortest, your answer will give you 1.16. This 1.16 is called the golden ratio because that's where the beauty comes from. You can use it also in plants, in other plants. You'll see how beautiful it is. In your arm, if you take the length of your arm, divided by half your arm, it will give you that 1.161. It's a recurring ratio. It implies that God also had that, even our paintings, even in music. Maths is beautiful. Let's love it. But I'll hand over to Mr. Bete to tell you more about this beautiful maths.
Good evening, and thank you, Mampho Langa. I will talk about addressing maths anxiety. It is something that is not often talked about, but it does exist. So I will start with a personal experience. Whenever I go to the shops, to the bank, home affairs, wherever, public places where you have to fill in forms, one of the questions you get asked is, what is your job or what is your profession? And when I say I'm a high school teacher, the next question is, what subject do you teach? And I'm always amazed at the reaction I get when I mention mathematics. I get responses such as, I was never good at maths, I was bad at maths, I hate maths, and I failed maths, but it's almost always negative. And that just shows you the perception of mathematics within society. And this notion, this negativity about mathematics, it's not new. It has always existed. I got this quotation, and it's actually a nursery rhyme, which was written in 1570. And it speaks to the negativity around mathematics. It says, multiplication is vexation, division is bad, the rule of three doth puzzle me, and practice drives me mad. So the negative perception about mathematics has always existed in society. So what is maths anxiety? This is a quote from Mark Ashcraft, and it says, it is a feeling of tension, apprehension, or fear that interferes with maths performance. So it's not just about feeling nervous, it's about these feelings directly impacting one's ability to perform in maths. Sorry, okay. Next one. All right. So maths anxiety, it's characterized by negative emotions towards the mathematics. And what it does is it acts as an emotional handbrake. It stops children from learning mathematics. And it varies in intensity from mild tension to deep-rooted fear of mathematics. Okay, it often goes unnoticed, it is invisible, and in some cases, maths anxiety appears as poor behavior, it appears as anger and frustration. It causes avoidance, and it's not just about being bad at maths, it's about how the fear and tension influence the behavior and self-perception in mathematics, and which often leads to feelings like of helplessness. So because of this, we need to look beyond the obvious symptoms of maths anxiety. Maths anxiety is not confined to the school environment. It cuts across all spheres of society. It goes from the young to the elderly. It appears in the home, in the workplace, everywhere in society. People struggle with maths anxiety. And also within the school, there's a perception that it's those who are not achieving well in mathematics who struggle with maths anxiety, but even high achievers struggle with maths anxiety. They can feel the immense pressure of being a high achiever in mathematics, and this immense pressure can trigger anxiety. So in that aspect, it's essential to support each and every learner. So just to give some perspective to what we are talking about and its effect and impact on the country, I've got this graph here about the statistics around the number of learners, which Mr. Nxasana alluded to earlier on. So from 2019 to 2021, we have just over 200,000 learners writing mathematics. Of those, only about 30,000 in 2020 and 34,000 in 2021 passed with a 60% and above, which allows them to study a Bachelor of Science degree. So in other words, we are saying 5% of those who wrote mathematics actually qualified to study a Bachelor of Science degree. So here I'm just highlighting the dire situation of mathematics in the country. Here's some statistics about maths anxiety from the UK. So 1 in 10 8 to 13-year-olds in Britain suffer from maths anxiety. A quarter of parents don't feel they're able to help their children or teach their children addition and multiplication without a calculator. There's so many other statistics which point to the prevalence of maths anxiety in that society. And I think it's no better in our own country, in our own society. So what causes maths anxiety? A huge factor that causes maths anxiety is social threats, which underscores the emotional aspect of learning. And when we talk about social threats here, we are talking about the humiliation, the fear of humiliation, the fear of exclusion, and the fear of being isolated or ridiculed by peers or even adults. So just to give an example, in class often, I ask a question and then I move around. I see that some learners, they've got the right answer on paper, but they don't raise their hand to give that answer. And when you ask why, they often tell you that I don't want to look or sound stupid in front of my peers. And that's a classical sign of maths anxiety. Another cause of maths anxiety is insufficient scaffolding or support in terms of learning mathematics. And as Mampho Langa said earlier, the lack of context or meaning, in other words, making it real and applicable to everyday life. So a fear of failure isn't just not understanding the material, it's about not being provided the right tools or context to grasp it. Within schools, some of the triggers are the difficulty with work, peer competition, gender bias, insensitive teaching methods, and lack of remediation. So it ranges from competitive environments to teacher behavior, and all these can amplify maths anxiety. And it's not limited to the school. Everyday scenarios can make everyday tasks become daunting for those suffering from maths anxiety. Things like sharing bills. Thank God to the cell phone with a calculator. It makes life a lot easier. You just whip out the phone and share the bill. Helping children with homework. A case in point here, I recently read a post on Facebook about a father who was talking about the struggle of helping children with maths homework. He was never good at maths and did not know how to help the child with maths homework. Some parents resort to saying things like, the maths these days is different, or, I don't understand how they do maths these days. But the underlying factor is that anxiety. What I liked about that father is he was just plain honest with his child to say, look, I did not do well at maths. I struggled with maths at school, but it doesn't mean that you will also struggle. If you put the effort, you will get better. So that's just an example of, everyday scenarios with maths anxiety. So understanding, digging a little bit deeper about maths anxiety, we need to be careful when diagnosing maths anxiety because the symptoms are quite similar to students with bad behavior. So they range from not starting work, spending too much time on easy questions, automatically responding, I don't know, to spoken questions, claiming they don't know where to start, saying the first number that comes to mind, not showing working out, or not completing or doing the bare minimum for homework. So those are also some of the similarities between what we term as lazy students and those who are suffering from maths anxiety. Maths anxiety cuts across the gender divide. My experience is that the female students, they are able to voice their anxiety, their struggles with mathematics more than the male students. And this might point to a deep cultural and social root about not speaking out and being able to speak out. So it's crucial not to jump to conclusion, but to foster an environment where all students feel safe in expressing their feelings. Knowing the students can be very helpful because it's about understanding their fears. It's not just about academic performance, but understanding their fears, their motivations and challenges. So a deep connection between the teacher and the learner can aid in identifying underlying issues. It's critical to differentiate between poor behavior and signs of maths anxiety. I'm quite certain a lot of students, and including myself, I have classified some students as behaving badly when it is just maths anxiety. So awareness of this is of critical importance. So understanding the root cause is essential for effective intervention. So some tools to help us support learners with maths anxiety. One of the biggest tools that we can equip learners who suffer from maths anxiety is to build their mathematical resilience. And here we use what is called a growth mindset. A growth mindset, it counters the notion that I'm not good at maths, and it challenges the belief that maths should always be easy. It builds motivation to persist even when faced with difficulty. So it fosters that belief in one's ability to do maths. The teacher's role in building mathematical resilience. Resilience is not something that we are born with. It is something that we can learn and cultivate as we grow. And teachers play a pivotal role in this process by appreciating the struggle that the learners are going through and encouraging persistence. I want to point out here that we need to understand that struggling with mathematics is not in itself bad. And it is projected as if you struggle with mathematics, then you are not good or it is a bad thing. But it is the struggle that builds the resilience. So teachers can reframe challenges as growth opportunities. We can also build mathematical resilience by making the mathematics tangible and relatable. Again, Mampho Langa alluded to some of the things that we can do. So in addition to that, by pointing out its presence in daily life or using visual aids to demystify the subject and make it more accessible. Diverse teaching techniques can help that cater to different learning styles to ensure that learners can find an entry point into understanding and appreciating mathematics. So we need to understand the students' needs, encourage everyday maths by just having regular maths chats, just talking about how, probably at home, what did you learn in maths? Even if you don't understand, the fact of talking about it demystifies, because maths is that one thing that everybody fears to talk about, everybody doesn't want to talk about and avoids. Okay, so what this points to is that we need to rethink our teaching approaches. I got this quote on the internet, and I think it speaks to the struggle with mathematics. In maths, we often ask children to climb a ladder where the rungs are missing. And this just adds and compounds to the math anxiety. So we can reduce anxiety by supporting those learners who are anxious about mathematics. We can do this by easing the time pressure. So often when teachers ask questions, we want quick answers, and we don't allow sufficient times for learners to think about what they have to say and give answers. So allowing more time to think and bring up responses can help. Proper scaffolding and depth. So the environment in which learners can learn will affect their attitude towards the subject. Reducing pressure and allowing thoughtful response can change the dynamics. And maths isn't just about formulas. It's about understanding deeply and holistically. Creativity can be a big part of supporting those in maths, with maths anxiety. Now, when people talk about creativity, we immediately think about the arts and such. But creativity exists in maths by making it relatable with real-world contexts. So, for example, I was doing a topic in Euclidean geometry with my grade 11s. There was a particularly tough question. But what I did was I just let them struggle, and one would think they've got it, and we encouraged, there was a spirit of encouraging each other, and then pointing out, but what about this? And they realize they are wrong. But the teamwork and the encouraging each other, you could see even those who are usually quiet started also participating. So by creating such an environment, learners become more creative in trying to solve the problem. Group work. Often mathematicians, they collaborate to make these huge discoveries that they do. And we should emulate that by allowing collaboration within the classrooms. And it's essential to break the stereotype that maths is a dry subject. Its beauty lies in the applicability and creativity of mathematics. And in addition, about collaboration, it fosters a sense of community. It reduces the fear of individual mistakes because now the whole group takes up ownership, and it stimulates rich discussions. Okay. So solutions beyond the school gates. So beyond the school, it is essential, for example, for business to bridge the gap between educational institutions and the workplace. One example could be people within the industries that involve mathematics coming to schools, speaking to the learners about their experiences, their struggles with mathematics, and making it more relatable and real. We should also celebrate diversity in STEM and challenge stereotypes around mathematics. There's a stereotype that, for example, men or males are better at mathematics than females, but yet there are many successful mathematicians who are female. A case in point, Mampho Langa here. And to broaden our horizons and spotlight on positive movements. We often celebrate the high-achieving mathematicians, but maybe how about if we celebrate even the maths and science teachers in the classrooms that our learners meet and experience on a daily basis, to say, if this person can do it, you can also do that. Parental and community involvement is essential. So building numerous skills and confidence in adults, inspiring lifelong learning, and engaging parents and carers effectively. So here we are talking about building a numerate and number confident nation as being essential if we want to tackle maths anxiety more widely. So for parents and carers who lack confidence or suffer from maths anxiety themselves, maths homework can be a daunting task. It can cause stress and make the negative reactions worse, with long-lasting consequences for both the parent and the child. Activities that are carried out at home can have a positive impact on a child's learning and perspective. So one game that I played with my child when he was young is the number plate game. So we would look out for, in that time there was triple digits on a number plate. So it was 3 letters, 3 numbers, then GP. So if you got matching numbers, we counted how many matching numbers he could see. So whether we are driving to school or to the mall. And it was a fun game. He was always looking out because obviously he wanted to win and be victorious. And as he grew up, we ramped it up by saying, if you get matching numbers and you add the total, whoever gets the highest total. So you are now introducing the aspect of addition, but through a game. Things like asking a child, here's the bill, we want to pay with 100 Rand, how much change? Sharing food, we've got so many sweets and there's 5 children, how many does each one get? So that demystifies mathematics, because mathematics is part of our life and we experience it every day. So in conclusion, the journey to tackle maths anxiety, it's not an individual or institutional responsibility, it's a societal effort. Changing perceptions, enhancing accessibility, and fostering enthusiasm for mathematics requires a holistic approach. Every step, whether small or significant, contributes to a brighter and math-confident future. And in conclusion, I just want to say that this presentation is just a snippet of the broader dialogue we must continually engage to transform the narrative around mathematics. Thank you so much.
Thank you. No, thanks very much. If I could just remind all of our viewers that if you have any questions, please put them in the chat. We already have a number of questions. But just to conclude, just the presentation that Mr. Bete has just made, as well as Mampho Langa, the issue of demystification of mathematics is particularly important. When I grew up, I think my parents understood this issue of demystification of mathematics. And they went to the extent, I'm Nxasana, my surname is Nxasana, and mathematics was sort of included in our surname. So we started calling our names or our surnames Nxasamatics. And all the games that we played, including the games that Mampho Langa was talking about, were actually part and parcel of learning about mathematics, and also making sure that us as siblings did not fear mathematics. And this was really, really important. And as it turned out, all of us actually did quite well in mathematics, because it was something that we didn't fear, it was something that we're not scared of, and it was really made to be enjoyable, to be fun, and so on. So there's a lot that we can do as parents to do this. Just looking at some of the questions that we have, the first one is being, how can a parent identify whether their children or their child has maths anxiety? I think it goes back to the point that Mr. Bete was saying. But let me hand over to you, Mampho Langa, and you, Mr. Bete, just to talk about what does a parent do? How do they even identify that their child may be experiencing or suffering from maths anxiety?
Mr. Bete?
So I think often when they are reluctant to talk about mathematics, so for example, if you ask them, do you have any homework? and they are free to talk about all the other homeworks except the maths homework, or you see them doing all the other homework except the maths homework. That's a classical sign that there's avoidance, which could be possibly a sign of maths anxiety. So when often you get reports from teachers that your child did not complete the homework, your child did not write the exercise, and in conversations with teachers, they will tell you that your child often does not get started in class, your child does not raise their hand. All those could be signs of maths anxiety in class.
Right. The second question, which is really a comment, but also there's a question in it, talks to the issue that we get what we measure as a country. And when you look at the issue of maths results, sitting where they are, just having been indicated by Mr. Bete in one of the slides, where we have a significant lower number of young people who are passing matric with mathematics. So the issue is a really important issue, and I'd like to just start off by agreeing with that sentiment. And it starts off, for instance, with the fact that when you look at the statistics that come out of the Department of Higher Education and Training, collected from universities that produce teachers, and you analyze how many preschool, foundation phase, or intermediate, in other words, primary school teachers are qualified to teach mathematics, you will find that as a country, a lot of people obviously would have chosen teaching, but when they choose teaching, for a number of reasons, they do not specialize in teaching mathematics. So numeracy at lower levels, at primary school, is a big issue, because that's where the problem actually starts. It's very late, it's too late by the time that the kids or our learners get to, for instance, grade 7 and 8, and hope that we're going to address the gaps that are missing in the foundational years, in other words, in their formative years of schooling in mathematics. And we have a number of universities here that really are not encouraging teachers, and maybe that includes government itself. So when you look at, for instance, the bursary schemes that are out there, including the own government bursary schemes, that should incentivize more teachers in preschool, in primary school, to take mathematics as a subject, that they teach at that level. It actually creates an environment where the base from which we're working by the time that we get to high school leads a lot of young people to maths literacy. But also there are incentives here, talking about the issue of what we measure. There are incentives here about the passes, the quantity of passes as opposed to the quality of passes. There are even schools that are stopping to offer mathematics in favor of maths literacy, as an example. And as we know, maths literacy actually leads to a lot of young people who are not able to pursue not just Bachelor of Science as an example, but all the other trades and vocations. If you want to go to a TVET college as an example, you want to go and do engineering, or you want to go and do a lot of the artisan, programs, you cannot get in there without mathematics, which essentially means we have a lot more people or young people who end up following humanities. Not that humanities are bad, but it's a supply and demand issue. You have a lot more people who are pursuing humanities degrees because they did not do maths. We end up with an oversupply, which is what we've had for a number of years in this country, which then leads to the mismatch in terms of what we need, in terms of learning, in terms of opportunities for the world of work, and therefore we end up with the high unemployment ratio that we have in the country. So it is a really important issue. As a country, we've got to address the structural and systemic issues around maths education, the production of teachers that are able to teach mathematics from the young age all the way up to high school. We need to work with families, just like the issue of reading is receiving a lot of attention. The same amount of attention has to be addressed when it comes to the issue of mathematics, because otherwise who are never going to be able to deal with the issue and the challenges that we face in the country. And we're going to continue having young people who are not able to realize their full potential simply because they didn't do mathematics. Moving on to the next question, maybe just on that point, Mampho Langa, do you want to add to that, to that issue?
Yeah, and quality is not only about the performance, because there's a likelihood that you might get the 60%, but are you able to apply whatever you've learned into real life? Because you can get a 60%, but when it comes now to a tertiary, where you're supposed now to start applying what you've learned from school, then there are problems there. And we've seen that especially in the sciences, where you find that students have memorized formula, they don't even know why they're using that formula. Then it becomes a problem. So it's not only just the percentage pass, it's how this maths has been taught in order to be applied in real life.
Yeah, the other question, which is a very important one, is a question, in fact, it's a comment that talks about the development of maths dictionaries in indigenous languages particularly. That, there are organizations that have started doing this. And it's an important issue because this issue of inaccessibility of mathematics, or the fact that, the language, going back to the point that Mampho Langa made, around the language, because mathematics is a language itself. And the way that it is delivered, expressed, or taught, or learned in schools, especially given the challenge that we as a country have, where the foundation phase, in other words, grade R1, 2, and 3, are taught in indigenous languages. You find that the issue of language of mathematics in indigenous languages is an issue that needs to be attended to. And these days, with the advent of artificial intelligence and machine learning and so on, there is an opportunity. And in fact, we've started working with some academics that are working in data science to see how artificial intelligence or machine learning and these large language models can be used to contextualize and produce terminology, lexicology, and language in mathematics in indigenous languages so that we can demystify mathematics. But that issue is a broader issue. It talks to the need for the country to address the language policy that we have. Because what happens is, from grade 4 onwards, the language of learning and teaching turns to English when the transition from indigenous languages is not properly managed in terms of the teachers, and making sure that the teachers are capacitated to do what they have to do, the learning and teaching material, the language, and so on. And therefore, by the time that the young people get to intermediate phase, in other words, grade 4, 5, and 6, and 7, you find that the foundations that they're supposed to have in mathematics, as well as reading for meaning, as an example, is lacking. And that leads to major problems by the time that our children get to high school, because they lack that foundational knowledge which they need. So there's an opportunity here for technology, for artificial intelligence, machine learning, large language models to actually develop solutions. But the likes of Google or OpenAI or ChatGPT are not going to solve this problem. It is up to us as Africans to participate in technology, to participate in artificial intelligence, in coming up with solutions that are going to create languages, dictionaries, lexicology in mathematics, because mathematics, after all, is a language. So yes, absolutely correct. And just looking at further comments, I think those were some of the key comments. There is another question here. How is society, lending support to the anxieties, by only rewarding, high achievers in mathematics and discouraging those who are average performers, and therefore perpetuating this issue of maths anxiety. I think it talks to the issue that Mr. Bete was talking to. In other words, we have to try and motivate those people who, every child, that I really truly believe every child has the ability to learn and understand and actually do well in mathematics. So by identifying the issues of maths anxiety, dealing with them, supporting young people in understanding mathematics and rewarding those that are doing well, not just the top performers. I think that way we would get a lot more young people start to have confidence in themselves in terms of learning mathematics and practicing mathematics. And that will create a much larger pool of young people who are pursuing mathematics. But I don't know, Ma'am Lang, if you want to add to that.
Yeah, just on that issue, we're talking rewarding mathematics. There are also other subjects that come into play. But why are we focusing on mathematics? People have a tendency of associating mathematics with high IQ, associating mathematics with being smart and all of that. So we need to demystify it even from our homes, because you even hear the parents going, this one is the smarter than the other one because he gets this in maths. But they never comment about that if it's just ordinary geography or ordinary other subjects. So, you know, that distinguishing factor also makes maths to be the subject, when other subjects should also get the same importance, it should get the same recognition. So it should start as early as from home, as early as at childhood level, where a child would know that it's not only about knowing maths for me to be smart, it's just to have knowledge of all the subjects. Mr. Bete, you wanted to add on that?
What I wanted to say was that the fact that we are talking about it as we do, because my experience is I haven't had many people talk about maths anxiety. Talking about it is a step in the right direction, because once you are aware, you are able to notice it in your child, in other people, and once it is noticed, it's something that can be dealt with through support and just providing the right environment. Because often the question is, why are you not doing well in maths? All the other subjects are good except maths, and then, it's all negative. And, without realizing that maybe this child needs support because they have maths anxiety.
Yeah. There's another question from Tibatso Mpati, who is saying, do we have the stats on the proportion of students who pass mathematics at 60% and plus at university, and what percentage actually complete their university degrees? We don't have that statistics, and the issue sometimes in South Africa, especially when it comes to tracking and doing longitudinal studies, is that when I look at the that comes out of the Department of Higher Education and Training. For starters, the data is often at least 2 years out or 2 years old. But also secondly, the completion rates when it comes to mathematics in the sciences, whether it's data science or economic sciences or even other areas, whether areas like, for instance, engineering, accounting and so on. The completion rates are on average, sort of not increasing significantly, which would indicate that there's a lot of work that needs to be done. But what's really pleasing when you look at the national senior certificates, though, is that we're starting to see an increase in the number of schools in the quintile 1, 2, and 3. In other words, these are schools in the poorer areas that are participating and doing mathematics and doing, reasonably well in mathematics. So that's a positive development. But what is worrying, just going back to the issue of statistics, is the fact that in total, in South Africa, when you look at the total statistics, number of learners that wrote the National Senior Certificate and those that are doing well in mathematics, those numbers are either static or even slightly, in real terms, going backwards. So that's certainly a big worry. Because the country must produce actuaries, data scientists, doctors, engineers, and so on, and technicians and artisans. out of those numbers that Mr. Bete showed earlier on. And clearly, that essentially means that the larger number of young people are not able to get into those professions or into those pursuits or into those vocations, which is a real problem because we continue to add to the challenge of unemployed young people or even unemployed graduates, because we have a lot more graduates who are finishing universities but not with the degrees that are going to create opportunities for people to meaningfully participate in the economy. So, yes, so a comment here from Mme. Helen about the point that Mme. Langa made, which is spot on about all subjects being associated, disciplines and having value. I think that's a really important issue because sometimes we focus, it talks to this issue of incentivizing mathematics at the expense of other subjects. Of course, we have a crisis in mathematics, but in trying to promote mathematics, we must not actually diminish other subjects that are also very important. Do you want to add to that comment?
Yeah, before I add to that comment, I would like to make a comment on the 60, 80. Your achievement at high school level, it's not equivalent to achievement at university. There are other important skills that have to be learned at high school to prepare the students for university. You can get 100% at high school level and not being able to survive at university. So whatever skills are taught at school level play an important role in you succeeding also at tertiary. And also on the issue of how we can make other subjects important, it's something that all of us should start talking about it. Mr. Bete indicated, at home, everywhere, and not associate mathematics with IQ of being smart. They have the same symbolic power. We always give mathematics a higher symbolic power, and it shouldn't. Then that way it will demystify that maths is difficult.
Yeah, which really then talks to the point that is made in the chat by Judy Lamini, who says she believes that the effort in mathematics, especially in terms of achieving in mathematics, needs to be rewarded as well, which is why the role of teachers in identifying effort and improvement over time becomes a really, really important issue. Because by doing so, we're actually building the confidence of the young people to understand that the more effort they spend in mathematics and the better they do in mathematics over time, that in itself is also going to be rewarded. So it's a very, very important point. And thank you for that. Any other closing comments or comments that you want to make?
I think I just want to add on the issue of rewarding. I think, when people talk about reward, we think probably something tangible or whatever. But I've seen, for example, a child gets 80%, and at parents' meetings, the parent is asking the child, they are more concerned about the 20% that the child didn't achieve, and instead of complimenting the 80% that the child got. And it's about that kind of mindset to say, look, the child has achieved 80%, let's compliment that and encourage to say, maybe next time you can do 85%. Over time, this child feels more confident and feel that they can, they are validated in what they are doing.
Yeah. No, thanks for that. Do you want any closing comments, Mme. Langa?
Well, let's emphasize on the growth mindset. If we can emphasize to children that failure is the beginning of challenges, and once you fail on something, and if you have that growth mindset that once I start failing, what can I do from that? Rather than focusing on that I failed, I cannot do it. Rather than saying I failed, what's the next step? How can I improve on that? Growth mindset is something we need to emphasize both at home and also at school. That failure does not mean it's the end of the world. It is just what you've done at that moment, and it is not a reflection, or it does not represent you. You can do better as you move on if you have that positive mindset that things can change.
Yeah, and there's a question here again from Tebato about whether there are tests that can check for or test for Maths-Nzati. I mean, you talked about, we talked about dyslexia, you talked about, the issue of challenges in mathematics.
Yeah.
Are there any tests?
The dyscalculia that I spoke about is the most neglected aspect of medicine, which I really feel we should bring in the professionals to give us more light on that, because dyslexia is getting a lot of attention. There's more people about it and more discoveries being done. So we need to call the medical field to come in and help us in the schools, because I didn't know much about it. I started learning about it lately now that I'm seeing that the problem is getting worse. Then I started knowing, dyscalculia, so we need more of the medical field to come in. And next time when we have conversations like that, we'd really need to invite the medical field people to highlight us on that, to give us some highlights on it.
Yeah. Now, great. With that, we really, again, would like to thank all our attendees in this webinar for having joined us this evening. This is a really important topic. And hopefully, we don't have all the answers, but hopefully we've all learned something, out of it. Obviously, there are major systemic or structural issues that as a country we've got to address when it comes to the crisis that we face as a country in mathematics. But there are things that you and I, as parents, can do in supporting our children to take up mathematics, not to fear mathematics, to identify anxieties in mathematics, but also as teachers, as educators. We have a very important role to play in making sure that the way that we teach, the way that we contextualize mathematics and demystify mathematics, it can encourage a lot more younger people and our children to take up mathematics and actually start to do well. And there are a number of really great suggestions and recommendations that have come out of the chat, and we would like to thank you sincerely for all of those. So with that, thank you very much. Thanks for attending. And until next time, we have an upcoming future talk on other topics. So if you just follow our socials as well as our website, we always try and make sure that we're talking about topical issues, and hopefully you continue to benefit from those. And thanks for joining us. We really, really appreciate it. Thank you. Have a good evening.
Welcome.